uh, software development, like building apps and the likes. I studied mathematical statistics, so that's a bit about myself. So this evening, I will just share my screen and we can dive straight into what we are discussing this evening. And please, I want it to be an interactive class, so I won't have to be speaking like I'm talking to myself all the way. My slides are not beautiful, don't mind me. Just have to quickly scrap up something this afternoon so that I can have something to guide our discussion this evening. I was given 2 hours, but then I'm not sure I will spend 2 hours because what I prepared for today is not really long like that. Tomorrow is good, but we can do some coding that will make it long. Sorry, can everybody hear me clearly?
Yeah.
Yes,
Like,
yeah.
continue.
Okay, thank you. Okay, so basically, we are talking on, according to the modules I was given, taking module for which is marketing and clustering analytics, and that's we leveraging data analytics for customer behavior and targeted marketing. This is actually a very good thing for me because this is around when I'm trying to analyze data of our own customers to bring about how we can. Don't worry, don't let me like break the ice. I will discuss some things with Mr. Ola maybe sometimes later. We are working on something that will like require us to use everything we are going to talk about today. So it's something like you are making me explain what I'm working on. So basically, so today's agenda. So today we are doing introduction to marketing and clustering analytics, customer segmentation using clustering, A/B testing for marketing campaign, and then question and answer, and we'll just wrap everything up there. So basically, tomorrow we'll be talking about sentiment analysis with NLP. That's okay. Don't worry. Then let me explain that now. We'll explain that tomorrow. Personalization and recommendation systems, case studies. So we'll talk about some case studies like maybe Netflix and YouTube and the likes. Then hands-on project, customer segmentation model. I've actually already prepared the notebook for that. I enjoyed the coding aspect. All this talking that we are doing is, well, we have to understand the basics before we jump into coding actually. So my goal here is to show you how data analytics transform marketing. Because long before now, okay, for example, if I asked most of us in this class, like, what is the predominant age of Nigerian farmers? Let's unmute ourselves and just maybe 3 or 4 people tell me the predominant age, like in your head now, what is the predominant age of Nigerian farmers? As you are thinking, like, what do you think their age bracket will be like? The mid age or the median age? Just unmute yourself and speak. I'm waiting. If nobody talks, we'll not
Okay.
continue.
My name is Elijah Basi, so I will pick 55.
55. Okay. Someone else?
Yes.
Okay, good evening.
Hello, my name is Henry. I'm going to pick 35.
Okay, my name is
35.
Paul.
Someone else?
I'm going to pick 50.
50. Someone else?
Yes.
Anyone else?
My name is Berakai, so I'm going with 45.
45.
I'm going with 45.
But you know, 45. Okay, makes sense. Any other person before I continue? Okay, let me just work with what I have. Someone said 55, someone said 35, someone said 50, someone said 45. Is any other person speaking? So the average age, like adding together what you guys said, the average age you guys are thinking is the mean age of Nigerian farmers is 46 point something. Let's just say 46. So that's the average age you guys think the average age of a Nigerian farmer is. But then, what if I tell you you might be wrong? I'm not saying my data is exhaustive, but then based on the farmers I'm working with, because I have a database of over 2,000 farmers in Nigeria right now, mostly in Ogun State. And I will tell you the average age is actually around 39. But the reason why most of us say 55, 50 is because we see that work as the work of some old people. But then without data, we can't actually make predictions. That's one of the major problems we are facing in Nigeria, and why what's it called now? This military president, Ibrahim Traore, what's his name, is making progress in his country. The reason basically is because he has data of the majority of the population. So he's able to like make intelligent decisions that will affect the majority of the populace, not just the minority. For example, if you are going to vote for anybody in Nigeria today, you vote for someone that has the money to do the campaign, buy the tickets and the likes like that. So the person will cater for people in his own, in his own category, in his own network, not the entire population. So we need data for things like that. So my goal today is to show you how data analytics can transform marketing. So now coming down to market, for example, a politician actually spoke to me some weeks back on how we can use this for his campaign in the forthcoming election. So we are not just using this in the normal day-to-day businesses again. We are now trying to adopt it into Nigerian politics. Imagine. So what you are learning today is like a loaded class, and what you are learning today is just a tip of the iceberg. But then you can always work more on it to see how you can like expand your knowledge in that area. Then we'll use analytics to understand customer behavior and boost ROI. The meaning of ROI is return on investment. So basically, we are using analytics to understand customer behavior. For example, most of you, if you've not noticed, if you enter YouTube, you might say, okay, I want to go and check this particular tutorial, or I want to go and watch this particular video. Then you end up spending the next 3 or 4 hours on YouTube. If you are not the lazy type like me, you might spend maybe 1 hour or 2 hours on YouTube. And the reason why you are doing that is because they've analyzed your data. They're not just analyzing your own data, like what you've watched in the past. They analyze data of people that watch the same thing as you. So what those guys are watching now is what they will recommend for you. So what you watched in the past, then the genre of the product that they will recommend, same thing on Netflix, same thing on TikTok and the likes like that. For example, they won't show me some content on YouTube, for example, whereas they will show it to my mother, because we are two different people, even though we are staying in the same house, and she's using my own hotspot sometimes. But then because we are two different people and they have our data, so they'll show us different things that are bespoke to us. If you notice, if you open a YouTube on an incognito window, you see things that you are not normally going to watch. But then because it's an incognito window, they don't have your data for that particular period of time that you are opening. But then by the time you use it for like 1 hour, they already know what they should recommend to you. So we will do some things around that. And how that will boost your ROI, that's your return on investment. YouTube wants you to spend more time on their platform. So when you spend more time on their platform, they show you more ads, meaning what? They make more money. So that's the way to boost your ROI. So that same thing applies to customers. If you have customers that are buying from you and you want them to buy more. For example, there was a case. This thing is actually dangerous to some extent. I will tell you the backside of it, but then I will tell you the positive side for your ROI. But then on the other end, it's something like you are invading other people's privacy. But then you are working for a corporation that wants to make more money, not whichever way they want to make it. But then we should respect people's privacy too. So today we'll cover segmentation. That's segmentation of targeting the right customer, A/B testing to optimize campaigns, NLP and recommendation system for deeper insights. Let's dive into this what's it called?
Sorry,
see how we can.
sorry, Mr. La, we can't see your slide. Like, we can't see your slide. Are you sharing?
You can't see my slide. I'm sharing my screen now.
Yes.
Can't you see my screen?
No, we can't see that. We can't see that.
Sorry. Oh, sorry. I thought I was sharing my screen. Sorry. I just got here. I did not press share. Sorry. Can you see my screen now?
Yes.
Oh, sorry. I've been like sharing my screen since. Let me just do a recap of what I've done so far. So we are doing marketing and clustering analytics. We are leveraging data analytics and customer behavior to target for targeted marketing. My name is Abasolaya. You've already heard all those things. So today we are doing introduction to marketing and customer analytics customer segmentation and using clustering, A/B testing and market campaign, question and answer, and we wrap up. Then tomorrow we are going to do sentiment analysis and NLP, personalization and recommendation system, case studies, hands-on projects, and customer segmentation models. So my goal today is to show you how data analytics transform marketing, how you can use it to boost your return on investment. And we're going to cover segmentation of targets, to target the right customers, A/B testing to optimize campaigns, NLP and recommendation system for deeper insight. Let's dive straight in. So now, I group the customer base sharing traits like age. So for example now, let me use the politician that I'm talking about to do this, to explain what's going on, how I'm going to segment my customers. If it comes to me and I don't have data yet, I'll say, okay, let's segment our customers based on age. You can't expect the old people to dance to songs like, what are these trendy songs these days? I Rasta. Well, old people will still watch I Rasta because she dances. But then, let me look for one. They will still listen to Johnny Brave. I beg, so okay. What's this guy's name? I don't really listen to hip hop like that. This guy that's advertises for Raimo, Burna Boy. You can't expect old people to like vibe to a song like that. If you're expecting old people in your rally, for example, if your target audience is old people, so you have to like segment. Okay, my customers, am I segmenting them by age? Is it by spending habits? Is it by location? For example, if you are staying in Ibadan, let me use Ibadan as an example. If you are staying in Kolakpo, or you are staying around Oluyole, or you are staying around Apata, or you are staying around Bodija, or you are staying around Bere, these 5 locations, they have a lot of things that differentiates them. Kolakpo Estate, the last time I went to price land in that place, they said a plot of land is 200 million naira. If you're going to buy land around Apata, you can still see land of say 12 million naira. If you're going to buy land in Oluyole Estate, there's no land in Oluyole Estate again. And most of the part of Oluyole Estate that you would like, they're already industrialized. So it's an industrial area. So now, are you segmenting your customers based on location? If you're segmenting your customers based on location, what's customers buying behavior in what's it called now? In Kolakpo Shola Estate is not the same buying behavior in Bere. Bere is a ghetto. Kolakpo Shola is a rich man's estate. So if I'm going to make, let's say I want to produce a new item, and my target audience is Kolakpo Shola, I'll work more on my branding. If my target audience is Bere, I'll work more on making the item cheap. I don't know if you get what I'm saying. So that's customer based, like the traits you are going to use to check what your customer, your target audience is. But then here we are talking about analytics. How you can use data to like solve all these things. So sorry, I bailed. So this helps us me to like craft a target campaign that resonates with my audience. Is my audience the young people or the old people? For example, I was doing a course on business development recently, and the man said, the man is in the US actually. He said, if you are targeting students don't have money. But if you are targeting professionals, they have money. But then if you are doing this, if you are using the same ideology in Nigeria, you'll be mistaken. You're saying students don't have money in Nigeria, you might be wrong. And you're saying professionals have money. Well, it depends on the professionals you're targeting. If you are in the oil and gas sector, most of them have money. But then if you're in something like banking sector, or maybe Nigerian-based fintech developers or something like that, most of them don't really have money. They have the knowledge, but then they don't really have money. But then most of these students, they are the ones that are like that buzzing, they are doing content and the likes like that, so they have money. So you can't just use the assumption of someone else's business in your own business, or another person's location in your own location. You have to like sit down with your own local data to be successful in any business. For example, one of the things I've heard is Nigeria has predominantly a number of behaviors that if you are successful as a business person in Nigeria, you can be successful anywhere in Africa, which is true. We have a number of geopolitical zones in Nigeria, and this geopolitical zone, if you are in Kano, for example, is a very different ball game if you are marketing in Ibadan, and it's a different ball game if you are marketing in a place like say Bayelsa. Everybody, I mean, these 2-3 locations have different behaviors totally. Let me even use close places. You're marketing in Lagos and you're marketing in Ibadan. It is 2 different things that you are doing. So you have to study data of people in Lagos before you can market to them. So you won't just be spending money and not get results. And if you are spending the same amount of money you are spending on marketing in Lagos, in Ibadan, you are wasting money. Because there are some things you can easily do in Ibadan and you get your customers. So that's what we are trying to study here. And so my go-to algorithms are actually K-means clustering and DB scan. So K-mean clustering is just basically it's you suggest, okay, I want 5 clusters. So it now divides your customers into those 5 distinct groups. But then DB scan, which is sorry. Sorry, I need water. So give me 2 minutes. Sorry for the break in transmission. So DB scan is basically density-based spatial clustering for application with noise. Don't mind the old shenanigan that looks long. It's not that long. It's not that difficult to understand. Density-based spatial clustering of application with noise. So basically what DB scan does is you don't need to like suggest maybe I want this number of clusters. It can find clusters for you. And what it basically does is it checks on what's going on. The density, it used a density criterion, like the ones that are close to each other. So it checks the what's it going to data of what's it going to close data points and clusters them together. And one of the major reasons why DB scan is preferable to other models is because it automatically like it recognizes noise. What do I mean by noise? Let's say we are analyzing data. Okay, let me use Nigerian workforce for example. Let's say I want to remove people that ghost workers from the payroll of Nigeria, and I analyze and I check the data. One of the first things I will do for me is I will do what's it called now? A box plot. Box plot will help me to see how many outliers I have. What do I mean by outlier? Outlier is basically a point that is uniquely far away from the center of the data. Let me use this illustration. Let's say I'm in let's say UI, and I'm talking to BSc students, that is people that are undergrads. And when I get their data and I check their ages, the ages I'm expecting is 18, 19, 20, 21, 22. Then if I'm seeing someone of 99, then that person is an outlier because the person does not belong in that class. What's a 99-year-old person doing BSc? They should be somewhere relaxing and resting. Or let's say I'm going back to my initial data of employees in Nigeria. I'm seeing data of a 6-year-old person being a civil servant. It does not make any sense. What would a 6-year-old person be doing in civil service in Nigeria? Based down of legal age itself. So I'll remove something like that. But then on a normal day, you should try and remove such data points from your data. But then when you're using DB scan, it can automatically do that for you. Hey, did I write a code for DB scan in my algorithm? No. Okay. So let's move to K-mean clustering now. So K-mean clustering, for you to do K-mean clustering, I told you the other time, you are going to pick a centroid, like that's the K number of number of clusters that you want. You pick it randomly. You can say I want 5, I want 3, I want 2. Then each customer gets assigned to the closest centroid. So basically what I'm saying is, let me quickly look for I did a plot this afternoon on that. This one is too neat. There is one I did that asks like the mark of the centroid when I was preparing for this class. It's not this one. What's going on? Why is my load? Okay. Shit. System is low. Oh yeah, damn low. I just want to show you what I mean by centroid. Answer me now. I did it on one of the, okay, this is it here. So what I mean by centroid is this, if you see, can you see my screen, guys?
Yes.
Hello?
Yes, you can.
So for example, here
Yes,
now
we
I pick
can.
3 centroids. So here is my first centroid, here is my second centroid, here is my third centroid. So if just no, if you are going, that will pick the centroid for you actually. So it picks it randomly. Then you start when you run your algorithm, it now uses that point and checks the closest, what's it called, the closest data points to it, and it starts clustering from there. But then it does some iterations such that it does not like make the mistake of just picking the data points to group together randomly. So let me go back to my slides before I come to actually run the code with us. So then I update my centroid based on the average assigned customers, average of the assigned customers. Then I repeat until the cluster stabilizes. That's basically what K-means clustering is doing. K-means is faster and simpler, but needs a predefined number of clusters. So that's basically like when you are running it on your system. What this basically means is when you're running it on your system, let's say you don't have GPU, it means it will run faster. If you're using K-means compared to DBscan, for example, using K-means you finish getting your solution faster than when you're using a more robust algorithm like DBscan. Then, but it can struggle with outliers, unlike DBscan. So I will double check my results. So when I use DBscan, basically it's just checking data density. It gives the customer in high density areas and flag outliers. So it flags them automatically itself. But then if you're using K-means clustering, you might need to do some data manipulation yourself before you actually run the algorithm. I'll make the notebook for this class available to the the organizers of this class, and I'll make my slides too available to them. So you can run these codes yourself later. I'll make some other slides, some other codes too as available for them, because most of the codes I write, I can't finish them in this class. I'll just use the one I prepared for this class, and I'll just run through the other one with you, because that one is a bit more robust. Why I like it, no need to guess the number of clusters, great to spot unusual clustering pattern, but challenge is that I need to tune my radius carefully for the best results. That's the drawback for DBscan. But besides that, it's the best you can think of. Let's go to our algorithm before we come back to A/B testing and optimizing our campaigns. Do we get what I've been explaining so far? Any question? Hello?
We are following.
Okay. So basically, in this notebook, I use just K-means clustering. So I won't start running the DBscan and it takes forever to run. Then data I'm using is an open source data that's available on Kaggle. That's the mall customer segmentation data. So when they provide this notebook to you, you can easily just click here and it take you straight to Kaggle, where you can easily download the data yourself. So this is the page for data on Kaggle. And you see other notebooks too that other people have prepared. My own is very straight to the point because of today's class. But then there are other code bases you can check here. For example, here is one person that has a silver this thing on Kaggle. So you can check through the person's notebook too and see how the person did his own analytics. You don't necessarily have to just follow what I did. So here I'm just importing my libraries. So I'm using pandas. Pandas is what's it called now? A analytics library. NumPy is an algebra library. sklearn has a number of I'm using cluster in sklearn, which has a number of analytics libraries in it. Matplotlib is for plotting. Seaborn is for beautiful plotting. So basically that's all these ones. Then I've told you about my data sets. You can also always import it. So here I was trying to import my data set, but then it wasn't working, was why I ran this code. But then it might be useful for you too. I was trying to import, so I was trying to get my working directory here. Then I was listing the files in my working directory. So these are the files in my working directory. Then the data I'm using is more customers.csv, which I told you how you import. So I'm checking for the head. When we say head, it means we want to see just the first 5 rows of our data, but then you can add a number inside this bracket to say I want to see maybe 10 or 20 or whatever. But then by default, it is 5. So that's that. Then my data processing. So basically what I'm doing here is I'm trying to check number of missing data. But then because it's not a data from the wild, what I mean by data from the wild is it's not a data from the day-to-day things. It's just a normal mold data that the meticulously gathered. So it does not really have missing data, like data points like that. Then I did my describe, which gives me the count, which is 200 data points. The mean age is 38.85. The mean spending score is 50.2. The standard deviation, the minimum, the 25th percentile, the 58th percentile, the 75th percentile, and the maximum. So do we understand what I mean by percentiles? Hello?
I think you can explain more.
Okay. What I mean by percentiles is basically what's it called now? Okay, let me use mean for as an example. Your mean is not a percentile actually. Your mean is your median. Let me use that one. 58 percentile is your median. So I believe all of us did statistics in secondary school. What we mean by median is when you arrange things. Let's say you arrange 100 things. What is in the middle? That's if you arrange 100 things, something in the 58th position and in the 54th position. Those will be the 2 things in the middle. But then you have to arrange them orderly. What I mean by orderly is from the highest to the lowest, or from the lowest to the highest. Whichever way you arrange them. Then the one in the middle is your median. So when we say 25th percentile, it means the one in the quarter position, the one in the 25th position when you are counting 100. But if it's a million, for example, it will be the one in the 40,000th position, something like that. So the one in the 25th percentile, that's what we mean by percentile. Then the 75th percentile is the one in the 3rd position. Do we get it now? I don't want to start doing math in this class.
Proceed.
Okay, makes sense. So then we have the k-mean clustering, which is what I've basically explained to you. So here I'm saying I want 3 clusters. Then my random state. This random state just helps me to get the same result every time I run it. If I don't set a random state, you will understand what I mean. Like my random state is 42. I've run it before, so I got this at this point. Let's count for a 3.05, 29.56. If I run it again, I should get exactly the same answer. But then if I remove this random state, if I run it 7 times, I will get 7 different results. Let me cut it. You can see it's a different result from what I got before. Then if I run it again, I'll still get a different result again. You can see that. But then if I add a random state, it helps me get the same result at every point. The reason I added the random state here is because you guys are going to run it too, and I want you guys to be able to get the same results with myself. What we mean by random states, if you are, how do I explain this now? The k-mean clustering, I told you if you pick a random positions to start doing the clustering. So the random position is more like the random state. The random state helps it to pick the same position at every point in time, whenever we are running this algorithm. It's not like your random table in the unit. Okay, you guys don't study statistics, sorry. But then the way you do when you do shuffle on your playlist, what you do when you do shuffle, it means it's picking a randomizer to randomize the audio files or the video files that you have. So here now we are now telling it use the 40-second randomizer at all times. So the 40-second randomizer, the first 3 figures in the randomizer will be the same at every point in time. So that's why we are getting the same results. But then if we don't put a random state, we are going to be using a different randomizer, because there's no algorithm that actually does randomization. It's just a randomizer that everybody uses. So when we do a random state, we pick the same randomizer at every point in time. But then when we don't use a random state, it picks a different randomizer at every point in time. So that's basically what I was trying to explain. Before I beat my own tongue now. So now visualizing what we have, basically what we are trying to do is we want to visualize where the random, what's going on, the random cluster points you picked are and how it actually sorted them out. So here is my plot now. So here is the plot. So here. If I run a different, if I run the random state, I should get almost a different plot. But it won't really be different like that per se. You can see it's a different plot. The yellow was here and the light like that. So let me just add my randomizer. So when I send the notebook, we can get the same answers. So now the interpretation of my results. So basically what we have is cluster 0, younger customers with high spending score, ideal for trendy product campaign. Then cluster 2, that's this the data scientist that's not giving them an overview of what you got. So now cluster 2, older customers with moderate spending targets with loyalty programs. So like our parents, you can target them with loyalty. Then middle-aged customers with lower spending focus on promotion to boost their engagement. So that's basically what we are explaining here. So here is what it means. The 0 is the younger, what's it called? Here. 0, so that's the younger customers with high spending score, ideal for trendy products. So here is ideal for trendy products, while the older customers are ideal for loyalty programs. So what we mean loyalty programs is well, then you guys know loyalty program. I don't need to start explaining that. Then the third one is cluster 2, middle-aged customers with low spending, focus on promotion and boost engagement. So that's what we have here. So that's basically the interpretation of the plots that we have. So now we are going to the A/B testing. What we mean by A/B testing basically is for better still. Should I go to A/B testing straight or go back and run some other algorithms? We still have a lot of time on our ends. So sorry, the next algorithm I'm going to run might be a bit cumbersome. In fact, it's not like a bit cumbersome, it's cumbersome. So that's basically it. So here, am I in downloads? So I'm still in downloads. But then, okay, sorry. Oh, this is the same data. This was when I was having problem with loading it the other time. Sorry. Then let's go to this data set. So here we are doing purchase analytics and predictive analytics. So this data is a bit cumbersome, but then brace yourself. Let's do some damages to this data set. So these are the libraries we are going to be using. We will import sklearn modules. We are using pre-processing, decomposition, clustering, Pico, linear model, matplotlib as Seaborn, then linear model or linear regression. Then this is our data. This is our data set. Yes. So our features are sex, marital status, age, education, income, occupation, settlement size. Oh, sorry, I prepared this notebook for people that don't have access to data set, but then you can easily get data sets online. But in case you don't have access to data set, you can generate data set randomly yourself. So that's what I did here. So basically, this is the range I'm generating data from, range 1 to 300. So here, so I generated this data myself. So in case you need to generate data, there's a way to generate data yourself. Oh yeah. Okay, it's still importing this. Oh, did I run any program that you're doing before? No. Why is it taking forever to import these libraries? Sorry for the breaking down. I don't know why. But I just wanted to show you, like, you can generate your data yourself, then you can like run the same model that we ran. So here we are doing what's it gonna 1, 2, 3, 4, 5, 5 clusters. And that's what I have here. Notice I'm still using the same random state 42. But choose my own lucky number. Sorry. You can use any random state you like. I'm just using the same random state so that we can get the same data set. But then I don't know why it's taking forever to finish running this.
But the notebook does not have.
But then it's not like it did.
Can you check the notebook? The notebook does not have kernel, no kernel. What are you running it on?
Oh no. Oh, it's on my local system. So show.
You can
Let's just move.
maybe
Okay.
launch.
Okay.
You
It's
can launch
restarted the
it
kernel
again.
now. Don't worry.
Yeah.
Yeah, that's what I just did. I refreshed the what's it called. So here we just imported the libraries that we need. Still taking forever. Okay, thank God. Then here we are visualizing the same head I told you the other time. So I just showing you that you can like import your own data set yourself. So you can run the normal describe and the likes. I just wanted to use this one to just do the normal clustering. That's why I ran it, and you can see that. So if I do a different random state to my data set, I'll get a different data set entirely. Then my clustering is different. You can see the clustering is different. But then to have the same data set all the time, that's what I'm doing. That. So that's that. So let's now delve into a more robust data set. So here we are doing, let me just restart this. Okay, here we are importing our libraries. So we have a number of libraries here. Don't worry, I'll just gloss through this note because it's actually a bit long. Then data preparation. So here we are importing our data and preparing it for analytics, basically. So that's, so yeah, I hope I've debugged this code because there might be a number of bugs. Then it's a learning opportunity. We all debug together. But then that's a long one. We are going to debug together though. Okay, and but then let me quickly explain what this code is doing basically. But then you can read the comments though. So I just highlight the comments so that you can. So we are doing creating and fitting a standard, standard scalar. That's something like we are just picture normalizing your data in your head. Then here we are adding some save the scalar. We are saving the scalar, applying PCA, that's principal component analytics. We are saving it. Then we are applying k-means here. I've explained k-means before. Then load scalar again, load PCA, load k-means, transform the predictions, then add segmentation labels. That we did there. Then here we load in some other data sets. Then purchase probability model. The yeah, you can just read through these comments yourself. But then the data set, I'm applying logistics regression here. Do we understand what logistics regression is, or I need to explain? Talk. Yeah, I'll assume we understand.
Please explain.
So I should explain logistics regression. So now, when we are doing when we are doing analytics, there are two types of analytics. We have the logistics analytics and we have the classification analytics. What I mean by logistics is, I said logistics, sorry, I said we have regression analytics and we have the classification analytics. What I mean by regression is we predict numbers. That is, let's say, want to predict amount, for example, that's number. We want to predict age, that's number. We want to predict score, that's number. But then, if we are predicting something like size, or we are predicting something like class, those are not numbers, they are not continuous variables, so they are classes. So logistic regression is a classification algorithm. Do we get it now? We can't like start doing the maths in this class, but then logistic regression is a classification algorithm that is we use to classify things into categories, say small, medium, large, say class 1, class 2, class 3, class 4. Once the data, the class, what we are predicting is not a continuous data. What I mean by continuous data is it starts from 0. That it can have decimal places, that can have decimal points. It's like 0.1, 0.2, you can have 1, it can have 1.2, 1.0, 1.7, 1.9, 2, 2 point something. But then classification is just like there are distinct number of classes. We can have 2 classes, we can have 5 classes, we can have 10 classes, we can have 20 classes. You know, for example, we are predicting colors. We have blue, we have green, we have red, we have indigo, we have magenta. We can have blue 0.2. So that's once we start having decimal places and the likes, once it's a continuous data, then it's a regression analytics. When it's a classification data, that is when we are doing classes and groups, it's a logistic regression. Do we get it? It's a logistic, is a classification model. Logistic regression is a classification model. So here we're just doing the model coefficient, that is, I don't want to start doing mathematics in this class, but then this is the coefficient of the model, that is when everything is set to 0, this will be the prediction. That's the easiest way for me to explain it. So here is our data set, and we are doing so we have price 1, price 2, price 3, price 4, price 5. So we did the normal description that we did the other time. Then here is the range. So we are just generating data points here between 0.5 and 3.5, and the difference between each of them is 0.01. So if you notice 0.5, then we have 0.51, 0.52, and the likes like that. Then here we are converting what we generated into a data frame. So here, then we have this. Then we run this. So these are our price points, and these are our mean PE. That's mean price elasticity. Then here, then we plot our price elasticity table. So here's what we have basically. I'm not sure you guys can understand what I'm doing here. It will require me to explain a lot of theories. But I will send this note. You can read the comments to understand better. This is actually real life analytics that I'm doing. So that's why the data points what I'm doing is a bit somehow. Let's go back to our slides so that I won't waste too much time explaining. Okay, let me use segmentation. Here. Probably you guys can understand segmentation. Okay, then these are our libraries. Then we have a data set that we are using that will send, obviously. Then here's our data sets. So we have sex, we have marital status, we have age, we have education, we have income, we have occupation, we have settlement size. Then segmentation, this is just the description of the segmentation. Then we are doing correlation estimates. So do you understand what I mean by correlation? Before I go on. Hello? Hello?
Hi.
Do we understand
Yes.
correlation?
Hi.
Yes, I
Hi.
understand correlation.
Yes, yes.
Anybody here that does not understand correlation? Okay, I will assume all of us understand correlation. So we're just doing correlation plot here. So we can easily visualize what our correlation looks like. You can see sex as a positive correlation with what's here? Marital status. Wait to sex as correlation with marital status. Probably, I'm not sure. But then it has a negative correlation with age. No, let's use something that makes sense. Age and marital status should have some correlation. Let's check. Negative correlation. Wow, that's interesting. Then age and what is this? Age and education. Yeah, age and education, we have a positive correlation. Obviously, the older you get, the more education you probably have. So that's basically this. So that's just a correlation analysis. So from the correlation, you can easily tell some things about the data set itself. Then we want to visualize our data. We are visualizing income against age. So that's what we did here. So you can see age. The age thing is like a line. It's something like a bar plot instead of a scatter plot. That's because age is like this. It's not like age is not really a continuous data like that. Like you have to be born on a certain day. There's no 1.2, 1.0. That's why it looks like a line. Then we are standardizing our data set. So I use the standard scale and not most of the time. But then now we want to do hierarchical clustering. That will return to us, return as a linkage matrix for us. So here's the hierarchical clustering that we did. So here is what we have. You can see how it breaks down into the different You can see the distance here. You can see how it breaks down into the different hierarchy in the clustering, in the cluster, basically. So we did transformation here, then we did hierarchical clustering for our data here. So it did the hierarchy for us and broke it down into the different hierarchies. But then this might be a bit difficult for me to explain to you guys, but then you see how data is like, you can easily like segment your data set. For example, I want to segment it into just two. And this like a distinction between them now. This one class and this another class. If I want to have 4, then I have this, and this. If I want to have 6, I can, and then you can see the different hierarchies have different distance. So you can like, oh, I want to enter this hierarchy and I want to break it down the more. So that's what this hierarchical clustering is helping us to do. But then we can use k-mean clustering that we understand better too. So this is the number of clusters that we have, k-mean clusterings. Then we are checking the number of clusters against the number. I mean, within cluster sum of square. So we are checking like the error within the clusters, the number of clusters that we have. So if we have 2 clusters, this is the amount of error that we have. If we have 3, this is the amount of error we have. We have 4, this is the amount of error that we have. And we have 10, but then 10 is too much. So we have to like strike a balance. Where do I want to stop? How much error am I allowing into my data set? So that's basically what that plot is helping us to detect. Then here is our k-mean model again. Then we are trying to segment our data set. So here's the segmentation of our data sets. So we have our sex. We standardize our data. So you have to like probably reverse this to understand exactly what this is telling you. Then this is our segmentation again. So well of few opportunities, standard, career focused. So this is how our clusters. We have 4 clusters now, and this is how we classify them. I don't know if you are getting what I'm saying. Hello.
Hi.
Are we there?
Yes.
So this is how we classify the data set that we have now. We have 4 clusters, and we are now like, oh, this one are well off, like the rich guys, the fewer opportunities, the standard, like they don't have, these ones don't have much opportunities, but then they're like me and you. Then the standard is like the regular Nigerian. Then the career focused, yes, the career focus. So that's what we basically did for our data set. So we classified them into 4 segments, and we labeled them so that the people in the field can know exactly which class which user belongs to. That's basically what we have. Then we did our our clustering. So what we did here is basically the k-mean clustering that we did. We now like use color to like recognize them. If you notice, the well-off are majorly on this side. Then the standard are like scattered around here. Then we have fewer opportunities around here. Then we have the career focused around here. That's if you are using it to check them now. You can see the 70 and 70 plus career focused here. But then that's what our data is telling us. Standard. I need to like analyze data again. Sorry, I'm talking to myself. Like I'm telling myself I need to like analyze data again.
Sorry,
70
Mr.
plus
Ola.
are career focused. Yes,
Someone asked a question, why do we need to standardize the data? Why do you need to normalize the
sorry,
data?
I wasn't. Okay. The reason we're analyzing data is because what's it called now? Our data is like scattered around. When I mean scattered around is it's okay. For example, you're checking age against salary. Age will be like numeric now. Most of us will not go up to get to 100. And if we are using amounts, I mean we are using salary. Some people earn in millions. So if you are now saying you want to analyze data and you are not standardizing, it's something like, okay, let me use this for an example. If they are paying you in dollars and they are paying me in naira, let's say we are being paid the equivalent amount of money, or even you are being paid more than me, your amount will look smaller than my own. But then if I standardize, like I standardize the ones in naira and I standardize the one in dollars, then it will help me to normalize them between a range like 0 to 1, I mean -1 to 1. So by so doing, it gives our data almost same weight. So the amount in dollars, the amount in naira, we have almost the same weight in our analytics. So one will not be like giving a preferential treatment over the other one. Do we get it?
Yes.
Hello.
Yes, we do.
Okay, thank you.
Yes, we do.
So that's that. But then this data I need to like reanalyze it actually, because what I'm saying here is people that are 70, I mean 60 to 70 are career focused. Wow, it's not possible. But then they might be career focused, maybe because data is not in Nigerian data actually. But then at that age, I should be retired and be enjoying my money. Then well off is this range, 20 to 30 to 40. We can say that's true to some extent because they are spending their parents' money, of course. So they are they've not gotten family and the lifestyle. So they will look well off. They can spend their money the way they like. Then we have the standard, that's the blue, they're just scattered everywhere. So standard is expected to be everywhere, obviously. Then we have the career focus is still giving me a headache, but then I'll leave it for now. Then principal component analytics. So that's what we have here. Then we plot it. If you notice, the reverse is the case here. Number of components we have, the higher the number of components that we have, the lower the higher the number of components we have, the higher the error. Unlike what's going came in clustering that has the different, what's it called now, a different. Okay, this one is cumulative explained variance. So sorry, I'm not making a mistake, but then it's still the same. It's still actually true. So that's so PCA applying it here. My plots. So component 1, component 2, component 3. Don't mind the way my component is stretching into under this thing. Then we are now doing the K-mean clustering for PCA. Oh, blah, blah, blah. Okay. So here it is K-means for PC. After we apply PCA to it. Yep. Then this our. Then when we plot our data set here, you can see a difference when we apply PCA. So our component analytics help us to like now classify them well. So we can like see a significant difference between the different components. Unlike when we're using just age. I like this plot, it's beautiful actually. But then like unlike when we just use our normal age, so you can look like always apply PCA before you like visualize. When you're using the normal age, you can see how scattered it is. But then PCA help us like group them well so we can see where each belongs to. So you can export your classification that you can like give the people that are in the field to like apply it for their marketing. That's basically what I did here. Like, do we understand anything? Do we gain anything from what I explained? Hello?
Yes, sir.
Okay.
Yes.
Okay, let's do a little bit of deep learning. How many of us have like used TensorFlow before? Or even if it's Keras?
I haven't.
Okay, do we understand data science? Like the normal data science, then we have deep learning, we have. How many of us have
Machine
done
learning.
the normal? How many of us have done data science normally? Why I start explaining something you might not understand.
I have.
Data science, anybody?
Yeah, I have.
Please just go ahead.
Okay, no problem.
Thank you.
So here is my data set, audio data.csv. Then this is well commented actually. So basically what we are doing here is we are breaking down our data set. Then we are breaking our data set into 3. That's the train, the validation, and the test. Okay, let me explain why but then I don't need to explain it if you guys have done data science before, but let me explain anyway. So the train data set is the ones that we are using to train our algorithm. The validation are the one we test them on while the deep learning is running. So you test them on it and see the error it's getting and improves on it. Then come back and test again on the validation data set. Then the test set is the one we test it on when we are done with the old deep learning, when we are done with the old deep learning model. So that's that. Then you can get the logic of what you're trying to achieve with this data set here. So then we import Numpy and TensorFlow. Okay, let's debug together. Better still, I think I'll flip it down. Okay. Fix it down. So basically, I'm running the deep learning model now. I can see my accuracy started from 0.7, that's like 17% to 87% to 88%, still on 88%, then to 89, 89, 89, 89, then to 90. You can see it's improving while it's learning over time. Then testing it on my model now. You can see my accuracy. I have 90.6% accuracy, 90.6% accuracy, which is quite good. But then if you're working on medical data, then this is quite bad. You have to like work more. But then if you're working on maybe for a loan company, getting 90% of your loan back is a very good, average for you. But then if you're working for health, if you kill 10 people out of 100 people, that's a bad one. So and this is just saving our model. I've shown yes, another one, predicting new data on new data. So this is our deep learning model again. Our audio.csv. Add maps. So that's that. So let's go back to our slides so we can get on with our day. Then A/B testing. So basically what we are doing with A/B testing is we are testing our model now in the wild. So we can have two different versions for the same class and test the two different, because you being able to like class your customers does not really do anything until you can actually apply some campaigns to them that brings you a reasonable result. For example, we've suggested loyalty membership for a class of our customers. So you have to like check how you can do the loyalty thing. Are you using, if you are sending an email, what are the type of words that you apply to your email that will bring about spam that will send the email to their spam? Or what are the types of wordings you use that would like resonate with them and make them want to buy from you? Then you introduce the loyalty, because you can't do a loyalty program for people that are not coming to your store at all. So that's where the A/B testing thing comes in. Then you now test the loyalty program on that class of users and see if it works. If it does not work, you have to go back to your drawing board and do the analytics again. So A/B testing is where you actually do the testing of your model and see how it works. Maybe you are going back to the analytics table, or you are going to just keep using your model. So the process of A/B testing is just set a goal. What is the goal you want to achieve with this new model you have? Oh, I click through rates. That's like maybe you are a blog site. You want them to, or let's use Temu for example. Temu did a lot of ads, so they will calculate their click through rates. Like how many people see our ads, how many people actually click. That's why they will now calculate their customer acquisition price. Like how much does it take them to acquire every customer they have. So let's say out of 200 people that watch their ads, only 20 click through and buy. So that's 220, that's 10%. So if each ad is costing them $1 and they are getting 20 out of 200, it means the cost of getting a customer is $10. So the next question now is, what's the customer lifetime value? It must be more than $10. We are using $10 to acquire the customer. So that's that. Then split audience randomly into A, B group. So what I mean by A, B group is, okay, now we've clustered our customers into 4 categories. So the first category is divide them into 2. Send this version of email to this ones and send this version of email to this other one. Then you see which one does better. Then the one that does better is what you now send to everybody, or you improve on it and send to everybody. Then measure the result and check the statistical significance. So that's that. Then tools you can use. I don't use them actually. I just said I use them. Google Optimizer and Optimizely. But then personally, you can just use your normal Excel sheet or use Python if you can. You're the type of person that likes coding like me. This ensures my campaign delivers the maximum impact. Because if you are doing something and you're not measuring it, you're just wasting your time. Okay. Okay, do you have any experience with A/B testing? Anybody? Or maybe you've done something that you have to test among a particular group of users before. Someone else talk, please. My mouth is getting dry.
I'm hearing it for the first time, sir.
Are you kidding me? Anybody that has heard about A/B testing in this class? Or you've done something that they have to test in the wild before? It might not necessarily be analytics.
Yeah.
Hello.
Hello?
Yeah, I think when we are doing A/B testing is when you are trying to test maybe 2 features and see which one is the user prefer or the customer um, enjoy or have satisfaction in it. So and that's trying to compare 2 things. So I think that's what I just know about.
That's actually A/B testing, actually.
Also
That's
done
actually A/B
A/B
testing. You're trying
testing.
to go ahead.
Yeah, A/B testing during CI/CD. I guess.
This person is a tech person. Continuous integration, continuous development. What's your background? Sorry.
Yeah, data science.
Data science. Okay. So CI/CD is actually like it's more like A/B test. So you continuously integrate new features, test new features, see how customers use them. There are some that you have to dump at the end of the day. There are some that you have to like continue working on. For example, how many of you remember? Do you know Google had a social media page at a point? What's the name again? Google. I forgot the name. But then they had a social media account. I mean, they created a social media platform at a point that people were using, but then they saw people were not really using it, so they had to abandon it. That's like them testing out their hands on social media area of things, and they saw it's not their calling. They had to let go of it and focus on other features. Same thing with what's it called now? The number of companies the number of things that you've heard of that companies actually spend money on, and then they saw like it's not going to work on the long run, so they have to just abandon ship and move to something else. So that's A/B testing. You're always testing. So that's same thing with whether if you work in any organization, you guys will like try new things. Oh, let's try this thing. Let's see if we can make money with this. Basically, what you're trying to do is see new ways your customers can use your service, and the reason why you want them to use your service is because you want to make more money from them. TP givers, for example, they did you saving your money on their platform thing. They saw people accepted it, so they doubled down on it and kept working on it and did some other areas of this thing. Okay, you can save for a month, you can lock it for some number of days and the likes like that. If it did not work, they would have migrated to something else. So that's basically A/B testing. You are testing out different things and seeing which one will work, which one will not work. That's that. So any challenge you'd like me to address so far?
Okay.
No challenge
Good
you would
evening.
like me to address today?
The challenges is maybe domiciled in that your note. So kindly send it. Remember to send it after the class so that we can go through it.
I'll do that. I'll send it to Mr. Ola. Mr. Ola will find a way to get it to across everywhere.
All right.
Okay.
Hello.
Hello.
Hello. Good evening. Yeah, my
Good
name
evening.
is Elijah. Yeah, one of the overwhelming things and is a big challenge for me when it comes to this SKLN package. It's filled with a lot of estimators or what we call algorithms. Sometimes how do you determine the particular algorithm to use in order to analyze your data? Because if you look out through the whole entire package, the library of SKLN, it consists of a whole lot of what's it called? Estimators. So as a
Models.
point, I get confused. Yes, models. I get confused when you have a question that you really want to answer a business question. Then which one? How do you determine you want to go for in order to be able to do your analysis? That's my question.
Okay, that's a very beautiful question actually, because I have a little bit of experience with what you are saying. Like it's a, let me use some unallowed words here. It's somewhat difficult to like say I want to pick this model, but then here's a very good start. What is the question I'm trying to solve at this point in time? What am I trying to predict? What am I trying to do? Am I working on a regression model, a classification model, or a, what's the other one? What's the name of this third model?
Clustering.
No, not clustering is okay. Yeah, there's clustering. So classification model, regression model, or not clustering. That is the name. Clustering is one of the models used there, but let's just call it clustering for now. So now, if we have this, no, then there's reinforcement learning. Reinforcement is another ball game, another motherfucker on its own. Sorry, I use motherfucker. It's another ball game on its own. Reinforcement learning is what self-driving cars are using, and all these robots that we see around. So we don't really have data to do that one. I don't have data for it. But if you are into gaming, if you program games, then you use reinforcement learning. I've done reinforcement learning maybe once or twice in my life. But then I've done clustering, I've done classification, I've done regression. So that's what's it called now. This is where you start. Okay, what's the question in front of me? Am I doing a regression problem, or am I doing a classification problem? Am I doing a clustering problem? So the different models in sklearn have what they do. So if you're doing regression, for example, if I'm doing regression, I won't think of logistic regression. I won't think of sklearn. I won't think of dbscan. I don't know if you're getting me. I will think of models that I can think of random forest. I can think of random tree. I can think of of normal regression. I can think of all those ones. If I'm doing clustering, I won't think of normal regression. I won't think of what's it called? I won't think of logistic regression. I'm doing clustering here. I don't know if you get what I'm saying. So what the type of question you are asking determines the model to use. But then, even regression model, we have over 30 regression models. So now, how do I pick which one to use for the problem at hand? That's the next question. But then, the better question is which one gives me the best accuracy, not which one would I use. So over time, while you keep on using different models for different things, you now see, oh, this one works for this type of problem. This one works for this type of problem. But then that takes practice. It's not something someone can tell you. For example, if you are the type of person that competes on cargo a lot, you would have noticed, oh, normal regression works for some things, it does not work for some things. Random forest works for some things, while random tree works for some things. Even though random forest contains a number of random trees, but the random trees are better at some things than random forest. So things like that. So you doing these things over time. And again, another thing is you changing from this model to another model might be the difference between you being the first on the leaderboard to you being the 60th person on the leaderboard. then you need to know how to fine tune your models too, how to clean your data and all those things. So that's basically how to pick the model you should use. Do you get it?
Yeah.
Did I help a little bit? I know I did not answer the question well, but then did I help a little bit?
Yeah, I'm able to pick up one or two things from what you said.
So, okay, if I may add one or two things to what you said, actually. So, picking or choosing appropriate model is a bit cheesy, kind of, in the sense that, first of all, you have to understand what's it called now? What kind of problem am I solving? Like you said, is it a regression problem? Is it a classification problem? So, if you identify that classification, it says that is it a binary output? Is it like what's it called? Multiple outputs, and regression, is it a single output? So, after identifying that, under each umbrella, for example, classification and regression, we have different model that can work under each umbrella now. So you have to now take different model under that umbrella and try them out. For example, now I've done some analysis with random forest, decision tree, XGBoost, and the likes before. And what I mean is that all those models fit into what I want to do. So after doing the classification and regression part, then I started trying them out one after the other and see the one that gives me the highest accuracy or RMSE, root mean square error. Another thing you can do is you have to understand the statistical or mathematical concept behind each algorithm. For example, now naive Bayes use probability, and it actually works best in NLP for text classification and stuff like that. And other ones, they use different type of mathematical concept or statistical concept. So you need to actually have some understanding of how those statistical concepts work and see how it can fit into what you are doing. So these are different ways that we actually try out to pick the best model. There's no one way thing to it. All right. If you I want to say something. Right.
Yeah. Also, the size of the data matters. There's some data that you just have to use deep learning. You can't use either of the machine learning algorithms. They will work, but you won't get as much accuracy or performance that you're expecting if you're expecting high. So sometimes the size of the matter also, the size of the data also matters, whether you use deep learning or regular machine learning. And also, Mr. Olai also mentioned cargo and what differentiates someone being the first on the table and someone being number 62 or something. From experience, I think even if you use the same algorithm, sometimes your hyperparameter can be the difference between the number 1 on the board and the number 30. So also hyperparameter tuning. Also, and that takes patience. So you try this, you try learning rate, you try different things. Just also hyperparameter tuning. Same algorithm, but different hyperparameters. So you tune it, you increase it, you reduce it, just like some kind of permutation and combination kind.
All right, thank you, Philo. That was brilliant. Yes, that's correct, like accurately. So these are the different ways you try out to actually determine the best model algorithm to use in data science. So, Mr. Ola, you can go ahead.
Any other question?
Okay, do we have any other question?